Hello, and welcome to another episode of Building Services using Serverless Architecture. My name is Srini Kalekar. I'm an architect and software engineer by trade. The best way to reach me is through Twitter or LinkedIn, and the handles are here on my first page of my slide. I would like to start off by thanking Cloud Academy for giving me this opportunity to share my ideas and project. Some of you might have been there for my last episode, where we built an intelligent SMS bot, which would recognize faces of anyone when you train it. Today, we'll build a Slack bot that will recognize celebrities, landmarks, and be able to extract text from images. All of this will be 100% serverless. This presentation itself is available at my GitHub. The link is here. You go to my GitHub. S. Kalekar, Chehra, and there's a folder called Presentation. Just click on that. Takes you to the PowerPoint slide. All right. So in the interest of time, I'm going to skip a couple of slides on the basics of serverless architecture, and going to hover over this this one particular slide before we continue. So the technique of building application using serverless architecture is also known as function as a service. The reason becomes clear when you contrast serverless application with traditionally built application, also known as platform as a service, where there is a perpetual process running on a server waiting for HTTP requests or API calls. In function as a service, there's no perpetual process for the most part, but an event mechanism that triggers the execution of a piece of code. Usually it's just a function, but you still need a perpetual gateway that will field your API calls to start the events to cascade. The other key operational difference between serverless application, and traditional web application is scaling. With most traditional applications, you still need to worry about scale. With serverless, the compute resources are provisioned at request level, so you cannot get the same level of granularity with the traditional application, even if you set it to auto scale. So that's one of the main advantages of going serverless. As a result of this, application built using serverless architecture are extremely easy to scale and very efficient when it comes to managing cost. But there are some shortcomings, or I would say something that you should be aware of when you're building application using serverless framework. One is state. You have to manage the state of the application yourself and store the state in a cache or external database. You also have to ensure that your functions are not running past a certain time limit. With AWS Lambda, there is a time limit of 5 minutes that you have to be aware of. There are ways to get around that by cascading Lambdas and using step functions. And as a matter of fact, we will be using step functions today to work on our Slack bot. There are certain resource limits that you have to be aware of. There is a max size of your deployment package. So we would, in the interest of time, I'm going to skip all that stuff and basically get into serverless framework. So this whole concept of function as a service was kickstarted by Amazon with their AWS Lambda, and was quickly followed by other providers like Google with their Google Functions and Microsoft with the Azure Functions and other IBM with the OpenWhisk, etc. Now, while it's very advantageous for you as a developer to just worry about building your business logic and not to worry about infrastructure, deploying it, patching it, that serverless provides. You do want to diversify risk by going into a multi-cloud environment. So that's where serverless framework comes to rescue. See, with serverless framework, you can write once and deploy it to multiple clouds, provided that the language is supported by serverless framework and also your providers. One such language today is JavaScript, which is ubiquitous and supported by multiple cloud providers. So having said that, let's take a look at a quick look at the structure of serverless framework. Serverless framework is an MIT open source project. It is supported by a very vibrant community. You can extend the framework to your needs if need be using the plugin architecture that they provide. And you can use that in your CI/CD process. You can call it from the command line using a rich set of commands. The serverless framework itself has a couple of core concepts. There is something called service, which is basically your organizational unit akin to microservice. It's where you define all your functions, and you do that using a file, configuration file. It's called serverless YAML, YAML. And this is where you define your functions. And function is basically your independent unit of deployment. It's where you write your stateless logic. And this function itself manifests with different providers in different ways. With Amazon, it is AWS Lambda. With Microsoft, it's Azure Functions. And with Google, it's called Google Cloud Functions. Now, we will get into an example, obviously, but just a quick high-level view. You have, in this particular example, we have a hello method, which is basically, you specify the handler as a file called handler.py, and the method is called hello. And give it a name. You can tell the runtime basically is, you can specify the runtime. I'm trying to remove this block here. Yes, you can specify the runtime. You can specify how much memory your function is going to use. You can also specify the timeout. Remember that I mentioned AWS Lambda has a time limit of 5 minutes max. So at the max limit, if your function is still running, the function will be terminated and you will get an exception. Okay, so functions are basically triggered by events, and this event could be anything specific to that provider. And in case of AWS, it is the AWS API gateway sending HTTP requests. It could be action that is as a result of somebody uploading a file into S3 buckets. It could be a CloudWatch timer, could be message coming into the topic, in this topic, or it could be an alert. And then there are resources. Resources are infrastructure components which your function uses. This could be a DynamoDB table for storing your state. It could be a S3 bucket or SNS topic. Obviously, for serverless framework to work across providers, it needs to know your credentials. There's a way to configure it, and I'm not going to get into that right now. There's links here which will provide you the details on if you want to do it yourself. It's very easy to create a service. Here in this particular example, I'm showing how to create a hello world. All you have to do is serverless create. You give a template. You're telling here it is the provider is AWS. It's a Python language function. The name of the function is hello world, and you give a folder name. I'm calling it hello world service. This will create a service, and then once you've done that, you deploy it. You deploy it using serverless deploy. I like to use a verbose myself because it gives me some detail and see what's happening behind the scenes. And then once you have deployed it, you can invoke it. There's two ways to invoke. If you want to test your function before you deploy it, you can invoke it locally, or you can invoke it through a deploy function directly, so it will call your Lambda function. In case of AWS, it calls your Lambda function directly. So that's a very high-level view of serverless framework. If you want more details or if you want to install it yourself, you can go to serverless.com, and there's a quick start there, which will get you started. Just go to the quick start docs, and this will tell you how to get started. All you have to do is say npm install serverless, and then we can skip the serverless login. Once you have installed it, you're good to go. All right, so now that we spoke about that, let's see what is AIaaS. Artificial Intelligence as a Service is another term for cognitive services. We now live in a golden age where a lot of these esoteric machine learning algorithms are commoditized by all these large cloud providers, so that ordinary person like me can wield them to build intelligent applications. So that's what we're going to do today. We are going to build a cognitive service, which is a SMS Slack bot. Which is a Slack bot. I'm calling it bot chair. All you do is, once you have built the bot, you invite the bot to your channel on Slack. I'm assuming that folks on this call or familiar with Slack. Slack is a communication medium for the agile world. And in this particular example, when you invite the bot to your channel, it will wait there and listen to events. If there's a file that is uploaded, it will see if that file is an image. If that file is an image, then it gets into action. It will analyze the file, and then it will see if there's any known landmarks. If there is a known landmark, it will find out the description. It'll give you a description of the landmark and also give you a link to the Google map. It will also detect celebrities. It will also detect text. So in the next slide, this is a pre-recorded demo. I'm uploading a file with certain celebrities, and let's see. There you go. It figured out who that is, and then when you click on the link, it will take you to the IMDb page. So that's cool. The next demo is a landmark detection. I'm uploading an image of Eiffel Tower. It will now come back and give you the link and description, and you can click on the map and you can take it for a spin. The next demo is text detection. So here, basically what I'm doing is I'm dragging and dropping a scanned document. It extracts the image, extracts the text from that image, and then you can now copy and paste it. You can also basically expand this to then translate that text into some other language if you want it. So now that we've seen that, the code itself is available at my GitHub site, Escalica Chera. So when you're done with this, you can go download it and play with it. It is, as I mentioned, it's a 100% serverless cognitive microservice built on top of serverless framework. The functions are written in Python, It uses Slack API, uses AWS step functions to orchestrate. For landmark detection, I'm using Google API. For text detection, I'm using Google API. For celebrity facial recognition, I'm using AWS recognition. And the step function will orchestrate this, and we'll get into that architecture in a bit. So this one here, this slide here, is the overall architecture, high-level architecture of the application. The right-hand side describes the installation flow, and the left-hand side describes the actual logic as and when events occur on Slack channel. So to begin with, you have to invite a user has to install the Slack bot into their workspace. And this, once you do that, it will Slack will send an authorization code to your application that's running on, in this particular case, it's running on AWS. And then from there, it will take the temporary code, go to Slack, get a permanent access token, and then information regarding your team's workspace, basically team data, and store that in Amazon DynamoDB. Once that is done, the next step is you wait for events to occur. As and when the events occur, the message gets sent to Slack sends the event to your application that's running your Lambda function running on AWS through the gateway, and Slack wants you to return a response back in I think it's three seconds. So you need to get that result back. So this is where you have to finish off whatever you're doing within 3 seconds, or send a response back and then do your operation asynchronously. So because image detection might take a little longer, I chose to break it up, whereby I send a response back and then in this example, as you can see, the orchestrator is called with the event data, and then that event data then is sent to an event processor. The event processor would then, based on the team or the workspace ID that is given, it will go and get the access token for the Slack workspace based on what was saved earlier, and then enriches the event with that information. And then it farms out this to various detectors. That detectors are basically other Lambda functions. There is a celebrity detector, landmark detector, and text detector. All of these are independent units, and basically they take that enriched event, extract the image URL from that, go to Slack, get the actual image, and then send it to its corresponding services that it's working with. As I mentioned earlier, the celebrity detector uses AWS recognition, and other two detectors uses Google Vision. The enriched event is then sent back to Slack. The enriched event is sent back to message poster. The message poster takes that, creates a report, and then sends it to Slack. Slack then forwards that to your channel on Slack. So that is a high-level architecture. This is basically what I just discussed, the installation flow here, and then there is the event flow that I discussed. So there's links there which will take you directly to the web page where you can find more details about it. This slide here is basically the step function. The reason why I'm using step function here is basically because with step function I can isolate each and every detection service, and in future I can add new detectors if need be. I can also chain detectors to other services. For example, translation service can be chained to the detect text service, so that once the detection is finished, it can then extract that text and translate it. You can use this in other environments where you want to blur images, if the image in question is not appropriate, stuff like that. So various things can be done. So with this, with step function, there's a plug and play architecture where you can do that. All right, so let's start building this one and go from there. If you're doing this yourself, I would suggest you start with this example here, which is a simple example of a hello world where you're using serverless framework to deploy microservices across two different cloud providers. One is, in this particular case, Google Vision, to get labels on an image that was uploaded, and that result is sent back to AWS Lambda, and then there it is taken and then further worked upon. So this is a good example of using serverless framework to deploy code across multiple cloud providers and bring them together. All right. So with that, I'm going to get started on building this Slack bot. In this, so I am copying. I created a directory called Cloud Academy. This directory is empty, so I'm going to clone. I'm going to clone the Git. You would need, if you're going to test this locally, you need to install Python. You can also do a quick test of your serverless setup by running a small hello world. And on my Git README, I have an instruction on how to do that. So in the interest of time, I'm going to skip that one. You need to then set up Google Cloud. And in Google Cloud, I'm going to go and create a new project. So basically, once you have set up your Google Cloud, you go to the section where you have your projects and then create a new project here. I'm going to call it Cloud Academy 1026. So it is working on it, as you can see here. Okay, so the project is available. So I'm going to switch to that project and then go to credentials. I'm going to create credentials here. And here there are multiple credentials that multiple ways where you can secure your APIs. Here I'm going to use a simple one called API key because I'm not going to do any I'm not going to make any changes to the service. It's going to be a read-only service. So I'm going to copy this one because I'll need this later. Next step is to enable your services. And then here I'm going to enable Google Cloud Vision. It's enabling the API. And there you go, it's done. You can see that it's now in disable mode, so it means that your API is enabled. All right, so that is Google setup. Now we go to Slack. In Slack, I need to create a new workspace. So this is going to send an email to me So let me go check that. All right. And I'm going to give a name. Yes, that's okay. And here you have to tell what you're using this for. I'm going to say other. I'll say it's a chatbot. 10 people. Got to give a name. So we get a URL, Cloud Academy bot. And we can skip this thing. All these instructions again is available on my site. Now that we have our Cloud Academy bot, the next step is to create an application. See, the reason for doing for people who are familiar with Slack, Slack is for conversations with other humans, but it can also be used for conversing with a bot. So to be able for your in the channel to be able to talk to a bot, obviously you need something behind that to carry on with the conversation with you. That's in Slack world, it's an application. So what we're doing now is I'm going to create an application and basically go here, say manage apps, and then click on build. And then say start building. And then give a name. I'm going to call it Cloud Academy bot. And then we'll create the workspace that we created earlier. And then click on create app. All right, so this would create your Slack app, but you need to now get the credentials for you to use this in your application on the cloud. So now that I have this Git, I'll go to my Git root and atom this directory. And then there's something called setenv.sh where you put your Slack ID and Google API key. We created a Google API key earlier. I think this, so I would copy and paste that here. And then here's where you get the Slack credentials and put it here. Slack credentials are basically the one from here. All right, so now that it's done, let's save this and go to our, make sure that it's saved. Make it an executable just to be sure. And source this. All right. So now that's done. Now that is done, a quick thing to do just for the sake of making your bot ready. You can add an icon here, and that icon is actually in your Git repos. There is a directory called Resources somewhere here, and you can. This is something that I want to use, so let's pull that. All right, so now that is added, the next step is to go and create a user that the user, what's called as a bot user, that will be the runtime user for that application. So you do that by going to your, going here and then clicking on bot users, and click on add bot user. I'll take the default name. Another thing that I need to do is set this bot as online, because this application is running externally and it's always available through our API gateway. I'm going to show that the bot is always online and available. Save the changes here, and then it's time to add a Slack installation button called Add to Slack button. And basically it is going back to your apps, just to be on the safe side. And then click on your bot, scroll down. Where am I? So your apps. And then I clicked on Cloud Academy bot. Yeah, there it is. So you scroll down and click on the Slack button here. Now, when you want to install your bot, make sure that you choose the right bot. And then click on this bot checkbox, and this would give you a snippet of code. This snippet of code is what will actually, this will generate this Add to Slack button. And when you click on this button, either you can click on this button and take you to your installation, or you can take this snippet and add it to a website that you're running on your company's organization server, or anywhere where a web server is running. In my case, I have installed that in a S3 bucket. I have an S3 bucket here. Let me show you that. So this is basically a static page with the JavaScript running, JavaScript and CSS. So when I click on this, it'll take me to this button. Now this one is the actual installation script, and I need to modify that with the information that we received because we created a brand new bot. So to be able to do that, I'm going to take the client ID and then go here to my site. The site is, I've created a site, sample site here. Let's go to the index.html, and I think around line 30, there is the section where it says replace me with your client ID. So just remove this one and then add your client ID. The client ID is available either here in your Slack button, this one here. This is the credentials that we copied earlier. So that should take us to, I forget if I have to put the codes or not. Let's try without the codes. Just undo it and see. Yep. All right, so that should take care of it. Now that I saved it, I need to update my S3 bucket, the index there. So I go to my Slack install. So this index.html is the one that we just updated just a second ago. So now we have done that. We need to copy this to our S3 bucket. And this S3 bucket is right there. So let's push that out. So before we push this out, I just want to show you that when you go here to this page, view the source. This one has a number. This is the client ID from our other bot. So this has to be replaced with a new one. The new one is this number here. It's ending with 6053. So let's make sure that happens. Okay, so it's been uploaded. So let's go and refresh this page. All right, and then let's view source and make sure that the page changed. 6053. The previous one was 7089. So we know that now we have the right add to Slack button. So this is going to now call our function, but obviously we have not installed our function. So if you click on it, it's not going to do anything. So next step is to actually install our code. So this is a good time to look at our serverless YAML and see what it is doing. So as I mentioned, this serverless YAML is serverless framework's version of describing your project. So in this case, you have a name. You can create your custom namespace and provide names, variable names that you can use in multiple places within this file. I'm saying that I'm using AWS as my cloud provider, runtime as Python, timeout is 60 seconds, and then I'm creating a couple of environment variables. And then I'm also going to create some IAM role statements. So the beauty about serverless framework is it not only takes your codes and deploys it, but also creates the necessary IAM roles. And if you want to use a specific IAM role, you can specify that here in the IAM role section. I'm here saying that I need my IAM role to have access to DynamoDB, be able to get and put items. I want to be able to allow execution of Lambda functions and also allow access to AWS recognition. My service itself consists of a couple of functions. The first function is the install Slack that we saw when we looked at the architecture diagram. So this is where this is a Lambda function that will be called when your add to Slack button is clicked. This will call the install path, and we'll get to that in a bit. And then there's handle events, which is what handles all your Slack events as things go on. The Slack handle events does what it does, and then hands over to process events. Process events is the one that calls your AWS step functions to do the processing. Now, within the AWS step functions, as you saw, there are multiple other functions, Lambda functions. So one is for celebrity detection, landmark detection, text detection, etc., etc. And then finally there's a post message, which then sends the detection report back to Slack. I'm defining my step function here. The step function is pretty simple, as you've seen in the picture. I have a parallel tasks. Each task is using a Lambda function, and then once they're all done, they aggregate at the post message. Post message aggregates all the reports and then ends the step function. And I have my DynamoDB resources that I'm defining, and then I'm also defining a couple of plugins that comes with to allow me to do step functions. All right. So that is the serverless YAML. The first thing is install Slack. Install Slack is the method that install Slack is a method that gets called. The process method gets called, as you saw here, serverless YAML. When you install Slack, there's a handler here. Handler is install Slack process. So install Slack process method. It's a simple method. Basically, I'm getting the temporary code that will come through the event, and from the event, from the code, I get the authorization code from Slack. So I take that authorization code and then go to Slack by calling Slack API and providing the code. The response will be my authorization token. Now that I get the authorization token, actually you'll get more than just a token. You'll also get the information regarding your workspace. So I'm going to save all that stuff in my DynamoDB next. And that's all there is to it. Once that's done, I send a response back. If everything goes fine, I send, irrespective of whether it goes, if it goes bad or goes well, I return a status code of 302. The only difference is if it's successful, I redirect to the success URL, which we will see in a bit. Otherwise, you'll get an error. You forward an error URL. All right, so that is install Slack, and then the next step is take a quick look at the handle events. So right here. It's gotta be a video. Handle events is so the way again you can look at that sequence diagram I have in the slide. Basically, what it does is there are two things that Slack wants you to do. First time you provide the URL, Slack will verify that it is sending the events to the right URL and it belongs to you by sending you a verification code. You have to match that verification code to your verification code, and if it's good, you send a challenge back. Otherwise, you process the event. So there are two types of event. One is a verification event, and the other one is a regular event. So in this particular case, I check if my event type is URL verification. If so, then I take the challenge from the body and send that as a response, so Slack knows that it's the code belongs to you. And then after that, I invoke the step function. The step function is basically, as I showed you, it basically farms out that to other step functions, other Lambda functions, and then it kicks off the detection process. Once it's all done, I return this method back. So this is going to be very quick and should be able to get done in a few seconds. So the asynchronous process will kick off, and that when you call the invoke step function, and that might take some time. That's okay. All right. So now that we've seen it, let's start running this and see how that goes. All right. So to start deploying it, I'm going to say SLS deploy. Okay, I'm in the wrong directory. I'll make sure that. So SLS is short form for serverless. You don't have to type in the full name. And this should deploy my code to AWS. Everything goes fine. It's taking some extra time today. All right, so it's successfully deployed it, and the two URLs are created. One is the install URL, other one is the post URL. So we are currently interested in this one, the first one here. I'm going to copy this, and once I've copied it, I'll show you a quick look at our Lambda, see if it is deployed. So you see that just a minute ago, we have this thing deployed. So if you click on any of this, you can see, let's say, the install Slack. Go to the environment variables. It has copied all the environment variables here that we defined on our serverless YAML. And it would create the necessary IAM roles needed for execution. It's created this Jira dev US East 1 Lambda role. So that's all good. Now let's go to Slack. And once I'm in Slack, I need to go to my app. And then go to my OAuth and permissions. And here, I need to add the new redirect URL. This is where I'm saying this is the install button. When someone clicks on the install button, this is what gets called. So I'm going to add that, and I'm going to save it. All right, so that is that. And now let's make sure that it works fine. And to be able to do that, we can go to the page that we had. And this is the page that we created. So I'll just refresh it just in case, and then add the Slack button. So you see that it says that bot user with the username Cloud Academy bot is trying to install the won't authorize. I say yes. Okay, so it says that the bot was successfully installed into your Slack team. That's awesome. All right, so the next step is to go and verify that your bot is actually added to your workspace. So you go to your workspace now, and you can see that under apps, there is Cloud Academy bot. So that way you can ensure that your Slack app is installed. Other thing that you can do is you can go to your services and see if that database is being created. A table is created, and there you go. There's that table that was created, and this item would be added. There's a Cloud Academy team that we created, and it has all the information regarding the team ID, the team name, and the access token. So we are good there. All right, so now that we verified, the next step is to configure our event webhook. So Slack uses this concept of webhooks. Whenever an event occurs, you can call that webhook with a list of events that you're subscribed to. So now we have to tell, we have to first give a permission to the Slackbot user to be able to send the event. That's one step. Other one is to subscribe to the events that you're interested in, and basically tell Slack to use that URL that you created earlier. All right. So to configure the event, so what I'm doing is I'm going to go to OAuth and permissions, and then in the select permission scopes, so I'm going to click on send messages as Cloud Academy bot. That's one thing. And then also I want to be able to access the file that has been uploaded. So I will create that. Yeah. So we added two permissions, and then I'm going to save the changes. All right, so once it's done, so if you go up here, I should have gotten it's interesting. Let's see if it works. I created, so add a bot user with username, this thing, and then this one. I should have got a message saying that to reinstall the app. I'm just going to go here and add to Slack just in case. Okay. Okay. And then now the next step is to enable the events. So I'm going to go to event subscriptions here. And then before I enable the events, I need to copy this. I have to specify where I want the events to be sent. And this is where I need to install this URL. This is the URL which gets called every time an event occurs. So as you can see, immediately what happens is Slack sends a verification to that URL. And if it's verified, you'll get a verified message here. All right, so the next step is basically specify what are the type of events that needs to be, what are the type of events that you're subscribing to. So click on this thing and specify message channels. Whatever comes in the message channel, we want that to be sent out to you. So did that. Next step is to, now that we are completed, we go here to the Slack bot, and then we are in general. Let's go to general and then invite the bot. So I think I did the right one. So I have so many bots that I did, so I hope I pulled the right one. All right, so okay, so it's already in the channel, so we have the right bot. Now time to test it. The moment of truth. So let me come here. Wait on my window. Go to my bit repos. I have a set of samples there. So directory called sample images. We upload the image. If everything goes well, we should get a message back. There you go. It found out who the users are, who the celebrities are, and gives you the link. You can click on that link and it will take you to the IMDb page. So it's cool. Let's send the image of a landmark there. And all right, so there you go. So that is, and similarly, you can do the same thing for text. So essentially what we did now was we created this bot and we were able to upload pictures. It was able to detect it using various cognitive services and was able to give you the report back. You can improve on this by chaining other types of services. So because of the plug and play nature of step functions, you can add new services, and those services would get the input from the service above it. So that way you can chain those services together to build an intelligent application. All right, so that's about it. I thank you all for attending this webinar, and hope you learned something from this as much as I did enjoyed building this up. Thank you.